Good morning. I hope you have waken up after yesterday's party. When we want to measure sustainability, it is quite difficult. There are so many parameters that we have to take into account, especially if we want to measure sustainability of cities, which are the crucial part of the transition to the more sustainable society, because most of the impact is in cities, but also it actually might be easier to increase efficiencies of life supporting system in the cities because everything is so concentrated. Our next speaker has developed an index that tries to answer that question. And our next speaker is a member of International Scientific Committee, Professor Siir Kilkis. She has done her PhD in KTH. She is now a senior researcher at Tubitak and associate professor in fields of energy economics and energy policy. And she is also an expert involved in International Energy Agency Annex 64 on optimized performance of energy supply systems with exergy principles. Siir, floor is yours.
Thank you, Professor Deutsch, for the kind introduction. It's a great pleasure to share the SDEWES City Index to benchmark the sustainability of urban energy, water, environment systems, and to envision scenarios for the future. Why cities? Cities use 365 exajoules of the total primary energy spending of our world, which represents 64%. And due to trends such as urbanization, this value is projected to increase by the year 2050 by a significant amount, which must be limited to at most 432 exajoules in a 2-degree scenario. And in an extrapolation of the recent beyond 2-degree scenario of the IEA, this amount must be limited to 390 exajoules, which is 42 exajoules reductions more than the previous scenario. According to the Global Carbon Project, there are some pathways for us to reach net zero emissions by the year 2050, and here we see 2 of them. One peaking in the year 2016, and the other peaking at the year 2020. The other 2 can be eliminated, one because there's not sufficient time, and the other one is not within the acceptable carbon budget. What is supporting this pathway that peaks at the year 2016? Well, energy-related CO2 emissions have remained stable for the past 3 years, which suggests that a rapid decrease in the CO2 emissions can be instigated. In addition, the strong base of research of SDEWES researchers are supporting more sustainable cities. Here we see some distribution of the cities being supported by SDEWES research in areas such as urban renewable energy systems, urban transport systems, urban waste systems, urban water systems, and urban governance system, covering topics such as district heating systems, 100% renewable energy systems, urban circular economy, and many, many others. In addition to the strong base of research, there's a need to strengthen the benchmarking of the science of cities. Science of cities expresses the metrication and the comparison of cities. So questions such as, in this case, for the SDEWES scope, can be answered for what is the energy usage, what are the CO2 emissions, what is the water footprint, and how may the performances be compared with one city, a second city, and multiple other cities to compare these cities and support future decisions. In this respect, the sustainable development of energy, water, and environment systems, the SDEWES City Index, has been developed, which contains 7 dimensions with 35 main indicators, and to date, it has been applied to 120 cities. Maybe it's not the 261 cities from which all of you come from, but the sample has been increased in subsequent SDEWES conferences. The first one being the capital and or largest cities of countries in Southeast Europe, followed by the cities with a port on the Mediterranean Sea basin for the 9th SDEWES Mediterranean Conference. Cities with the most authors in the 9th SDEWES Book of Abstracts was included in another sample, followed by a second sample of cities in the Southeast Europe region. Next, multiple criteria was used to increase the diversity of the sample. So in addition to European cities, North African cities, 4 cities in Latin America and Asia were also integrated. And for this year, in the SDEWES Index Atlas, 18 new cities has been integrated with additional of 4 cities in Africa and the Pacific, with an additional criteria that these cities have released a monitoring report or an equivalent data submitted within the last 2 years. In addition to this, cities from the previous sample, 50 altogether, have released more updated data, particularly in the Covenant of Mayors for Climate and Energy. Here we see the monitoring report submitted this year by Lisbon, in addition to local plans, statistical yearbooks, and those in various databases. When we look at all the signatories of the Covenant of Mayors, there has been a reduction of 36% in buildings and 7% in transport. So these cities are moving very fast towards their target reductions. In addition, a supporting questionnaire was sent to the energy and sustainability managers of cities to obtain their most recent data for this year's SDEWES index. Plus, there has been other developments in areas such as demonstrations of pilot districts, global urban ambient air pollution database, and compliance with the Urban Wastewater Treatment Directive, among many others. So all of this data has been updated in the dimensions of energy, usage, and climate in the first dimension. Second, penetration of energy and CO2 saving measures. Third, renewable energy potential and utilization, followed by water usage and environmental quality. The fifth, sixth, and seventh dimensions are respectively CO2 emissions and industrial profile, urban planning and social welfare, and R&D, innovation, and sustainability policy. Let's look at the indicators dimension by dimension. In the first dimension, the indicators are energy usage of buildings in transport and energy usage per capita, followed by total degree days for climate, and final to primary energy ratio. The indicators in the second dimension are based on the scoring of the presence of an action plan for energy and CO2 emissions, followed by the energy system characteristics, energy savings in buildings, density of the public transport network, and efficient public lighting measures. These indicators also include sub-indicators such as developments towards fourth-generation district heating networks and the total urban rail per kilometer squared, and any bicycle sharing stations if present in the city. In the third dimension, the indicators for renewable energy potential and utilization are the renewable energy potential for solar, wind, and geothermal energy, and for the utilization of this renewable energy, the renewable energy in electricity production, followed by the green energy share in transport. For water usage and environmental quality, the indicators consist of water consumption per capita, the water quality index, that looks into dissolved oxygen, pH level, conductivity, nitrogen, and phosphorus, and the annual mean particulate matter 10 concentration from urban monitoring stations, followed by the ecological footprint per capita and biocapacity per capita. When we look at the indicators in the fifth dimension, the indicators consist of CO2 emissions of buildings, of transport, and the average CO2 intensity. The number of CO2-intense industries for EU ETS industries are necessary because these are not covered in the Sustainable Energy and Climate Action Plans, as well as the airport carbon accreditation level and related measures for the land side, ground handling, and air side of the airports servicing these cities. For urban planning and social welfare, the indicators consist of waste and wastewater management, compact urban form and green spaces, gross domestic product per capita, inequality-adjusted well-being, and tertiary education rate, with sub-indicators on recycling and composting share, and the share of green area in urban area, and the share of impermeable surfaces, both of which are important towards developments for water-wise cities. In addition, this sprawl index is looking at whether that city is imposing additional pressures for land use changes. In the dimension of R&D, innovation, and sustainability policy, the indicators look at the policy orientation, what are the priorities, are there priorities for sustainable and smart communities, the national patents in clean technologies for building technologies, energy generation, transport, and smart grid, the local, public, private universities and institutions supporting these cities, the national H index, and the reduction targets for CO2 emissions, all of which must be orchestrated to support the CO2 emission reductions of these cities. In total, while all of this data for the cities were collected and normalized based on the minimum and maximum value in the data set, with a winceration of any outliers according to higher order moments, which means that the next value is substituted for any outliers, 4,200 inputs have been obtained, and for a spatial and visual representation of this data, they have been transferred to a SDEWES index atlas, which answers the question, what are the quartiles of cities' performance? So for the 120 cities, 30 cities in each quartile will be shared. In the first dimension, here on the right side, we see the average city performance, so it is possible to see what the average city performs like. And this outer ring shows the maximum value for the indicators, with the inner ring showing the value that the average city gained in those indicators, the normalized values. And when we look at the bottom 25th percentile, we see that the cities are having below median performances from 61% up to 12% below the median value, and progressing through the second quartile, and now to the third quartile with above median performances. And the top 25% shows that best practice examples can be given by cities such as Tirana, which stands out in relatively low energy per capita, and Karlovac, which has improved its performance from previous years based on reductions in energy usage in buildings and transport, respectively by about 10% and more than 40% from previous reportings. In the second dimension, for the scoring of the penetration of energy and CO2 saving measures, we see that cities that perform in the bottom 25%, they are having performances again well below the median, while in the second quartile, they are improving their performances to converge to the median value. And in the third quartile, these are the cities with above median performances. And in the top 25% of the second dimension, we see cities with performances above 25% to 58% above the median value. And this indicates that best practice examples can be given from cities such as Copenhagen, which has a district heating coverage of 98%, and Budapest, which has a good daily ridership and urban rail density for the city, among other strengths. For renewable energy potential and utilization, let's again look at the quartile performances of the cities. These are the cities in the lowest 25 percentile, followed by cities that are converging again to the median value, and those cities that are in the above median category. And in the top 25%, we can look at cities such as Rio de Janeiro and Reykjavik as best practice examples. While the average city performance in the renewable energy share in electricity sector was about 35%, these cities are performing well above the renewable energy share in electricity. In Rio de Janeiro, this has been increased to about 81%, which involved 10% improvement in 1 year. And in Reykjavik, it has already reached 100% renewable energy electricity sector based on geothermal energy, but challenges remain in decarbonizing the transport sector. In water usage and environmental quality, we can see that the mean performance of the annual mean particulate matter 10 concentrations, they are a little bit above the World Health Organization recommendations. But in the cities that are improving in the quartile dimension, we can see some below median performances converging to the median performances, the above median performances, and in those cities, in top 25%, from which examples can be given from Helsinki and Gothenburg, for example, we see that this value is improved among improvement in other indicators. In Helsinki and Dubrovnik, there are reductions in favorable values of annual mean particulate matter concentrations. In Dubrovnik, this is 12.6 micrograms per meter cubed. And we see that there are improvements over the average city in the remaining indicators. For CO2 emissions in industrial profile, again, we will see similar lack of performance below the average city and vice versa. For example, in the lowest 25%, some cities are performing below 94% below the median value. And in the second quartile, we see a convergence towards the median performance, followed by cities in the top 50 to 75% and the top 25%. And examples can be given from Karlskrona and Stockholm. For example, in Stockholm, the CO2 intensity is 0.14 per tons CO2 per megawatt hour, which has improved from the previous reporting. In urban planning and social welfare, we see that there's a sprawl index value of close to 1%, which means that additional pressures on land use changes are being put. And in the cities in the lowest 25%, again, these are showing various distributions from cities around the world. And in these second and third quartiles, these are cities very close to the median values of performance. And in top 25%, we see cities that have performances from 16 to 52% above the median value, from which best practice examples can be given from Aalborg and Gothenburg. In Aalborg, there is a relatively low permeable surface ratio in the city, which indicates that there are more area for water to return to the water reservoirs. And in Gothenburg, the sprawl index is negative, which indicates that this city is not sprawling, but rather contracting. In a dimension for R&D, innovation, and sustainability policy, we can see that some of these cities are performing below the median value from 74 to 17%, and in the second, third, and top 25% performances. Best practice examples can be given from London and Berlin. Both of these cities have strong university and research institution base to support the CO2 targets of the cities. Once these values from all of the indicators are aggregated per city, and the weights are 75% for the energy usage and climate and CO2 emissions dimensions, and 55% for the remaining dimensions, we see that the SDEWES index performance of an average city from a possible maximum score of 50 is 28, score of 28 over 50. And a valid question can be, how can we tour around the world with the SDEWES Index Atlas? Well, here we see the cities in the lower 25%, and for all of the dimensions, we see cities performing about 47 to 7% below the median value. And continuing with our tour with the SDEWES Index, for the next quartile, for the second quartile, for 25 to 50%, these cities are those that are cities slightly below the median value, but getting close and hopefully converging to higher performances in the future. And looking at the third quartile, we see cities that are performing slightly above the median value, from about 1% to 5%. And in the top 25% of the cities, these are the cities with the best performances, the 30 cities with the highest performances based on the results of the SDEWES index. Let's look at how possible changes can arise from random weights applied to the indicators in the SDEWES index. For this, 10,000 Monte Carlo simulations were applied to the cities in the sample, and from this we see that once the 10,000 Monte Carlo simulations are applied and ordered again to their mean values, there is no change in rank in the lower 25% of the cities. This quartile is stable. We can characterize this quartile as the challenge cities of the sample, with cities that are faced with challenges in multiple dimensions, including Cape Town and Christchurch, but this does not mean that there are positive developments in these cities. For example, in Cape Town, there's promising developments from the Cape Town Energy 2040 roadmap, and in Christchurch, the city is prioritizing sustainable urban development in the rebuilding process. In the Monte Carlo simulations for the second quartile, there are two positions in which change in rank take place between Antwerp and Madrid and Sevilla and Calamaria. But these are close ranks, and we can again consider this quartile as relatively very stable and characterize this quartile, all the cities in this quartile, as the solution-seeking cities. These cities have less challenges than the previous quartile, but again, they are needed for strategic approaches to improve their performances. And we can give examples from Hamburg and Funchal. In Hamburg, one district is already 100% renewable energy, but the rest of the city is, there's coal in the energy mix. And in Funchal, there's fossil fuel dependence, but the island is seeking for a smart energy island. The Monte Carlo simulations for the third quartile show there are again two places in which there's an exchange of ranks. And again, this quartile is relatively stable, and we characterize this as the transitioning cities, cities that have strengths and that can be readily transformed into opportunities to improve their performances. And examples can be given from Genova and Sydney. In Sydney, there's a decentralized energy master plan, including low-carbon infrastructure zones, integrate 100% renewable energy systems, including power to gas, and a gas network supported by the wastewater treatment plant, as well as dairy farms close to the metropole. In the Monte Carlo simulations for the top 25%, these are, again, the leading cities in the sample. There is stability in the Monte Carlo simulations, and we can characterize these cities as the pioneering cities, the cities with strengths in multiple dimensions. So we came from the challenge cities, the solution-seeking cities, the transitioning cities to the pioneering cities. And examples can be given, among others, from Ljubljana and Copenhagen. In Ljubljana, there's the promising development of a sustainable urban strategy as well as a zero-waste strategy for the city. But the SDEWES index is beyond the ranking. It is also about promoting collaboration and city-to-city learning between the cities. So, for this, a pattern search algorithm has been applied to search for those cities that are above, at, or below the average city performance in the same dimensions across all dimensions. So these are twinning the cities with the SDEWES index. Based on the search algorithm, 12 city pairs between two cities has been found, and 13 city pairs between 3 or more cities has been found, for a total of 33 different cities altogether between 97 cities. One city pair includes the pairs of the cities of Ohrid, Isola, Celje, and we can see there's total 5 cities in the sample. We can see that there's a need to improve performances. Here in the inner ring, we see above average performances, but those that are below average, it is only marked by half, and we see some need to improve performance in several dimensions. One idea, and you may have many more, is that a possible area of collaboration is sea or lake-based heat pumps and or aquifer thermal energy storage to support the penetration of renewable energy. And the relative weakness in the R&D and innovation base for sustainability can be made by more researchers collaborating with these cities. In these cities, in the collaboration pair involving Zadar, Pula, Cluj-Napoca, among others, this is one of the most grouped collaboration pair. Possible areas of collaboration to improve the performances to be above average in the marked dimensions can be, for example, the utilization of residual heat from industry. There's food and beverage industry near Zadar, non-metallic minerals near Pula, and thermal power generation, waste heat from main activity, thermal power generation near Timișoara. In the cities in the collaboration pair involving Calamaria, Nitra, Bursa, Nilüfer, Sfax, and Batna, one best practice example from Nitra includes about a 40% coverage of geothermal energy in district heating system. Possible areas of collaboration can be to reverse the present case of using high-exergy heating of buildings in these cities of Kala Maria, Bursa, Nilüfer, Sfax, and Batna, with possible best practices such as from Nitra. And in all of the cities in this collaboration pair, there's a need to improve the recycling and composting share. Currently, in these cities, it is between 1 and 15%. So there's a need to also diffuse the separate collection that will improve and support greater recycling rates in the future. In this collaboration pair, we see some best practice examples. And again, these best practice examples can be diffused among the cities in the collaboration pair, including penetration of energy and CO2 saving measures in buildings and transport, and the utilization of residual heat from industry. In the collaboration pair with Vienna, Nice, Barcelona, Grenoble, and Grand Lyon, one best practice example from Vienna is holistic refurbishment of a low-energy district and successful examples of net zero buildings. Possible areas of collaboration, these cities still have relatively higher ecological footprint, so this can be improved, along with utilization of residual heat from industry that can also help in this respect. The city pair that has above average performances in all of the dimensions for a well-rounded approach is the cities Copenhagen, Helsinki, and Aarhus. The leader can be seen as Copenhagen, which also has the first ranking in the SDEWES index. There is also low temperature district heating in the suburbs of Copenhagen, but as well as Aarhus. So we can see some further collaboration among these cities, but more importantly, among all of the other cities to diffuse their best practices. And an opposite performance to this city pair is the city pair of Johannesburg and Bogota. These cities have below average performances in all of the dimensions. For example, combined heat and power is only used in certain data centers in Johannesburg, and there's a reliance on coal-based power generation. And in Bogota, the potential for solar and waste energy has been mapped, but this potential is yet to be fully realized. So transfer of knowledge from pioneering to challenge cities will also be an important area of collaboration. Some city pairs have only strengths in, for example, R&D and innovation. And for example, in Bangalore and Istanbul, the airport energy system is more advanced than the city energy system. In Bangalore, on-site solar PV provides a significant share of the airport electricity, and this is going to be fully powered by solar energy in the future. And there is an opportunity to improve the performances. In the collaboration pair of Seferihisar, Karlovac, Funchal, and Tirana, there are certain strengths, such as high share renewable energy and electricity generation, but also certain weaknesses. And possible exemplary opportunities can be given from Seferihisar, which is just currently looking into a project to utilize the geothermal resources for electricity production, greenhouse heating, and tourism, followed by other cities in the region. In the city pair with Paris, Antwerp, Antioch, and Nagoya, district heating networks are developed in these cities, with one of the most successful examples from Paris. The existing sewage system network has been used to expand the district cooling network, and further collaboration can be possible with the other cities. And the realization of a smart city requires smart energy behavior, and the smart reuse of resources. And Glasgow is trying to address this with the utilization of renewable energy supported by new behavioral habits within a smart grid scheme. And there's areas for further collaboration in this. And in a previous plenary lecture, a proposal was made for Cologne to have demand-side management, energy storage, heat pump, and power to gas for the city. So further developments are possible. In the city pair involving Heraklion, continued improvements in air quality are necessary. These are above the World Health Organization guidelines. And further developments are upcoming, which are currently not reflected in the SDEWES index because projects will be complete in 2019, for example, for Eskişehir Tepebaşı, including a low energy district area. The shared economy holds promise to transform the future of cities. And one interesting example is open district heating, which is being implemented in Stockholm. Agreements between the energy company is being made with anyone who wants to provide waste heat into the district heating system, including data centers, which are very promising. And there are other examples from Stockholm, including a 90% fossil fuel-free city fleet and biogas procurement for waste trucks. and pilot facility for biochar. Possible areas for collaboration include open district heating, for resource-neutral networks involving 100% renewable or recycled fuels. Other areas of collaboration for the other city pairs: increased CO2 targets support by R&D, transition to renewable energy systems, and Maribor, for example, has updated the existing district heating network into a combined heat and power-based network, and plans for including solar energy is included in the plans for the future. Let's ask the question, what if the future of cities were SDEWES aware, and how can a possible proposal for this vision be put forth? Well, cities can use energy resources rationally at the right amount, quality, and time towards 100% renewable energy systems, and linking the water dimension while acting to preserve water resources proactively. And in the environment, cities should seek integration whenever possible to valorize limited natural resources in better respect of environmental balances. The vision for the SDEWES-aware city is linking the systems for urban energy system, urban water system, and environment systems to reach the vision, the proposed vision for a SDEWES-aware city. Let's think of possible scenarios. What are some possible scenarios? Recently, the new version of the Heat Roadmap Europe for Pan-European Thermal Atlas PETA 4.2 has been put forth, and we can see here very clearly that the theoretical excess heat annually is very significant for very much the entire cities for which this has been put forth, including Cologne, Hamburg, and London. There are significant excess heat possibilities. If we remember, these cities were also part of a collaboration pair. So what if this collaboration pair used such a scenario to improve their performances with the utilization of residual heat, the utilization of bio-waste and urban biomass, and matching energy use savings in a matching amount? So let's see how the performances showed. This was the previous performances, and cities were able to improve their performances by an average of 10 ranks. And for example, in Cologne, which had the most change in rank, the city progressed from a rank of 93 to a rank of 55 and advanced to the next quartile, the third quartile. Additional possibilities are possible with continued increase in the utilization of renewable energy potential. And the second scenario, what if similar scenarios were applied to a subset of these cities in the SDEWES index sample? This corresponds, according to the country coverage, corresponds to 60 cities with the SDEWES sample, and a possible scenario can be defined as the utilization of residual heat within approximately 15 kilometers based on a scenario multiplier. This can be changed in other scenarios as well as the available bio-waste, the urban biomass, and end-use savings, as well as for those cities in the Stratego project, residual heat and wastewater can be used with a given multiplier. For the 60 cities to which this scenario has been applied, we can see that some cities improve their ranks within the same quartile, but especially these lined boxes are where the cities are progressing to the next quartile, so they're able to jump from one quartile to the next. So these are the cities with the most improvements, significant improvements. But in all cities, they are competing with one another, so they are competing for the same ranks. For the cities to which the scenario was not applied, these cities are not able to maintain their position, so they're retreating to the worser ranks within the sample. So guaranteeing the rank in the SDEWES index is not guaranteed unless continual improvements are made. And this indicates that the average city performance is not static, it is dynamic, it will change over time. What are some of the foresights? What are some of the trends that are impacting the average performance of cities? Based on references in the literature, we can give some foresight. For example, cities upgrade to at least 3% of their building stock to zero or near zero emissions each year. And by the year 2015, emissions from deforestation and land use changes in cities will be cut to zero. By the year 2030, mass transit utilization in cities doubles. And this is another one. For 2035, the electricity sector reaches carbon neutrality. And by the year 2040, renewables obtain a 100% share in primary energy usage, given a doubling every 5.4 years. And at the limit, by the year 2050, the world as a whole will reach net zero CO2 emissions. So backcasting these targets to intermediate targets for the given years, it is possible to apply these reductions to the performance of the average city and project to certain years up to the year 2050. And also considering the share of energy efficiency measures and renewable energy measures within the beyond 2 degree scenario of the IEA, we see that energy efficiency loses shares year by year, for which in the year 2050, renewable energy will compose 63% of the foreseen reductions in CO2 emissions. And further innovative concepts such as fourth generation district heating networks can surpass the annual per annum ratios that are perhaps involved in these scenarios. So in one scenario, in another scenario, can we close the gap from the average city with the best performing city in each indicator? The scenario is the average city catches the performance of the best performing city per indicator of the SDEWES index by target year. So for the year 2035, the average city will reach the performance of Reykjavik, and for the year 2025, the performance of Rio de Janeiro and Stockholm, and so forth. Can this be possible? This was the answer for one scenario. And we see here that by the year 2025, the average city, which are these aqua blue colored circles, will be able to catch the performance of the best performing cities. There will be no cities for which the average city is above or below the average, but reach the performance of Copenhagen by the year 2025. Well, one advantage of this scenario is that it is assuming a rapid improvement in all indicators simultaneously to reach the best level of performance by target year. So this is challenging, but this scenario is a scenario and we should seek for it. When we look into projection to the year 2050, for the year 2030, the Sustainable Development Goals, clean energy, sustainable cities and communities, clean water, climate change, also including quality education, and responsible consumption, the average city can reach a performance of 39 out of 50, and by the year 2050, the average city can reach 45 out of 50 possible scores in the SDEWES index. So it is catching all the cities, the average cities, it's reaching a very high benchmark with some cities above and some cities below, but for a very high benchmark. So there's a convergence between the average and best possible performances for these cities. What are some steps that decision makers can use and utilize while applying the SDEWES index to their own cities? First, decision makers can check the city performance, evaluate the overall score and dimension performance of a specific city, seeing whether it is above, below, or at the average performance level. And most importantly, solutions should be sought that look at increasing the value of multiple indicators with solutions. So solutions addressing multiple improvements with the same solution, in decreasing energy usage, increasing renewable energy, and limiting the environmental impact. As a third step, or anywhere in between, there should be city-to-city learning for paired cities, cities in the same quartile, or cities within the same index quartile or dimension quartile, for collaborative efforts. And most importantly, integrated action in all of the dimensions. So sectors are not limiting the view, but cross-sectoral views are adopted, and solutions can be given from diffusion of renewable energy solutions in all sectors, and increased opportunities for sharing waste heat in urban areas. And demand response is a very important solution, but not only limited to the energy sector. The water sector can also be a very good domain for which demand responses can be implemented. And the reduction of material energy, water substitution for the city, co-location of energy and water utilities for research exchanges, and improvements in water planning to reduce climate risks. In publications, several tools has been proposed. So there are benchmarking tools available as put forth in the publications. And a sample of pilot projects and developments from the sample cities that show integration of energy, water, environment systems and the sectors. For example, in Murgia, a PEM fuel cell is used in the wastewater treatment plant, And in Dubrovnik, there's a co-location of energy and water sectors, so solar energy is placed in the building of the waterworks utility. And in Amsterdam, the urban and intercity rail network is using 100% renewable electricity and putting some building integrated photovoltaics into the stations. And in Aarhus, for example, is one of the cities with low temperature district heating network. And in Budapest, near Budapest, there's a 10 megawatt power to gas facility driven by flexible load. In Christchurch, the airport is using groundwater for cooling and heating. And in Riga, there is a multi-apartment residential buildings that will capture the waste heat and use it for the buildings. Additional opportunities can involve smart island system for Funchal. And we see some other examples from the other cities. Copenhagen is seeking to be the first climate-neutral city in the world. And it is very exciting to see the developments of the cities. So in the first plenary lecture, it was mentioned that courage leads to happiness. Will the cities have the courage to produce and share as much energy as used on an annual basis? Will the cities have courage to preserve water resources for net zero water impact? Will the cities have courage to increase circular waste management to achieve net zero waste? And will the cities have courage for rapid progress towards net zero emissions? I believe, and we believe, that the answer is a very strong yes, because of the wealth of knowledge and the wealth of solutions by SDEWES researchers. Cities will contribute to bending the curve by the year 2020. A SDEWES-aware city is an integrative city. A SDEWES-aware city is a collaborative city. A SDEWES-aware city is your city. Long live our planet as we know it. Thank you.
Thank you for really impressive number crunching, data and quantity of information. And I'm extremely happy that Lisbon and Zagreb, my two home cities, are a pair. Because in a way they're both very livable cities, with some problems, of course, but I liked living in both of them. I'm opening the floor for discussion, and it seems we have a very urgent question from Jiří.
Okay, thank you. I've got a few questions. How you define city? You know, because city of Manchester has got 200,000 people, no industry, it's mainly university. Greater Manchester is about 20 cities, very different. So this is one, city of Westminster, London, and others. How you consider that each city has got different position and situation? There are cities which don't need heating and don't need cooling because they are blessed by the nature. And there are cities which need, say, heating most of the time. This is another issue. Issue about CO2. I don't think CO2 is a major issue for a city. It's for the globe, for the world. But for cities is the major issue haze and smoke. And haze and smoke are not only emissions, it's not CO2 at all, but there are NOxes, SOxes, and PM, where it is in the index. And also you need to consider that technology is developing. We are now going not to integrative city, we are going to smart cities. And there are some indicators which are very much outdated. Number of changing points for bicycles. In Beijing, it's about 2 million. Because now with the technology, you can pick up the bike wherever, you've got them all over, with smart application, and you can take them. So everything is developing, and I think it should be very much considered a move to smart cities and change the indicators which are more acceptable for smart cities.
Before I let you answer, I must say I deeply disagree with you, Jiří, on CO2. Because cities are where we can do maybe 80% of action on CO2 mitigation. I agree with you that CO2 is not poisoning people. Those are other pollutants. But making the world more sustainable, it's critical to use cities for reduction of CO2. Sorry, Siir. Yes, but we want cities to become also CO2 neutral. No, it's connected. If we remove diesels from city, we remove the haze, but we also decrease CO2. Sorry.
So Professor Klemisch has 4 questions for me. How do you define a city? The climate context of the cities, how is it evaluated? The air quality and CO2 related question. And the 4th one, we should go towards the smart city. I want to start from the last question and go backwards. I'm currently in the position of proposing a national initiative for Turkey for smart and sustainable cities, because when I looked into 17 programs around the world, we see smart city being defined in very different ways. But for example, in Europe, it is very consistent, the use of ICT in energy, transport, and all the sectors. But for example, when we look at Singapore, they're not using the term smart city, they're looking at the term sustainable city. And sustainable city is very well defined in their context to include sustainable energy, sustainable water, sustainable transport, and I see that sustainability is supporting the smart city context, but sometimes even going beyond the smart city context into what Singapore proposes as a sustainable urban solutions platform. So in that context, I see that the indicators are supporting the smart and sustainable cities. Maybe I'm not looking into how much ICT is used in buildings and transport, but if there are successful implementation of ICT, which putting more sensors in the city does not necessarily mean that that will be successful. Sometimes putting more sensors will not achieve the results. If there are successful implementations such as that, which are already monitored by the European information system for smart cities, it will reflect in indicators such as energy or energy usage in buildings, in transport, and CO2 emissions. So I'm not measuring maybe ICT usage directly, but if there are successful examples, maybe water reductions, reductions in ecological footprint, and vice versa. So going to the first question, how to define a city? How to define a city? Yes, there can be some urban agglomeration perspective of a city and different perspectives, but when I look into the data sources for which I rely, for example, Sustainable Energy Action Plan for Lyon is adopted for the Grand Lyon perspective, and data is provided for Grand Lyon. So in this case, the definition of a city is constrained to how the Sustainable Energy Action Plan has been applied to. So if they applied as a metropole, then I considered that as a metropole. But you will see that scope defined in the Sustainable Energy and Climate Plans. For the second solution, for the second question for the climate, there's an indicator for total degree days, and this is also weighted by the coefficient of performance, seasonal coefficient of performance for heating and cooling. So if a city has high heating degree days and low cooling degree days, it will be maybe somewhere in between. Only cooling degree days, no heating degree days like in Bangalore, then it will gain all these points from the cooling degree days, and a city with relatively high heating degree day and relatively maybe high cooling degree days, it will also receive scoring, but this is accounted for the dimension, energy usage and climate, and particularly for the total degree days. And I believe I answered my best to give answers to all 4 questions.
We had another question, Zdravko.
Thank you. I just went to internet and find out that the proportion of people living in urban cities is more than half of the whole population,
Yes.
which is really a lot.
Yes.
So I think, Neven, you are right. CO2 emissions and that kind of things is very important and related to cities. What I'm thinking is our behavior. I think we do not behave right. So the question is, could it be possible to involve in this analysis a kind of change management principles which would involve the determination, our willingness to change our behavior to be more green and so on?
I believe so, and cities realizing and foreseeing the urbanization trend will increase in future years, they are very much engaged in supporting the sustainability of the urban context, and they're seeking to engage the citizens when designing their policies. So that process of involving the citizenry in determining the future of a city, it can have multiple benefits. First, making the citizens aware of what their energy future, water future, environment future can be, and also, based on that awareness, allow them to have take-home messages that will enable behavioral changes in the behaviors of the citizens themselves, so they can be empowered to shape their future, whatever the decision-making of that collective citizenry could be. Awareness is very much supporting the implementation and realization of those targets. I believe so.
Thank you very much.
Michael? Or Timothy? Oh, wow.
Both of them.
Both of them.
The co-authors.
Father and a son. Shall we give advantage to the senior?
I'll pull rank on the young fella. Question about how a city improves its performance. A lot of initiatives require the support of the city council,
Yes.
Getting the political support of the people. And they get voted every so many years and so on. It costs money. So if you have a city that people enjoy living in, and there's a lot of happy citizens there, and it goes along with the changes, then I can see how more things will happen. So your ranking there is pretty interesting. Have you seen how it correlates sort of with the happiness rankings or the livable city sort of rankings that you see in the newspapers from time to time? Just to see whether, you know, the metrics are heading in a direction that the people
Yes.
end up saying, hey, this is great, I love living here, give me a 10 for my city.
In published research, of course, I've looked into many things while working on the SDEWES index, but in published research, I included a comparison and how the city performance is correlating to the Human Development Index. So when a city is located in a country that has a higher Human Development Index, how is it performing and how is this diversified? So in published research in Journal of SDEWES, which is an article in press, and you can just press that article in press button at the top, you can see that in my upcoming publication in this very valuable journal, the comparison with the Human Development Index is put forth. I'm also curious to look whether the correlation will be similar to Happy Planet Index or so forth, but already one indicator is looking at the inequality-adjusted well-being, which is based on a survey administered to the citizens, asking them, what is your experience and happiness with the daily experience? Are you suffering? Are you thriving? What is it? And the maximum score is 10. So in the urban planning and social welfare dimension, which is the 6th dimension, this inequality-adjusted well-being is already one of the indicators. So it is already reflected or representing the scores of the SDEWES index, but maybe just isolating that one indicator and seeing how it will change can be further published in upcoming publications.
Okay, Tim, and then it will be Ilya and Peter.
Okay, I have a couple of, I guess, comments and questions. The first one is, I found it interesting that you decided to pair cities together that were of a similar rank.
Yes.
Wouldn't it make more sense to pair a city of a lower rank with a higher rank so they could learn from someone who's doing something better?
Yes.
As opposed to pairing cities that are doing the same thing and therefore not improving?
Actually, both is considered in this city pairing with Copenhagen, Aarhus, the 3 cities in that pair, I tried to show as one example. I didn't have time to go into, but there are some opposites within the SDEWES index city pairs. So cities having above average performance in all dimensions and cities with the below average performance in all dimensions. This is our common understanding of city twinning, and the European programs has been opening programs for city twinning under this mentality between a lagger and a leader. But this year is the first time that they also opened a call for cities with similar performance. So cities with their leaders or laggers, it doesn't matter, but cities with similar performance can also be twinned and get their activities supported in this twinning context. So in the steps for decision makers, I wanted to propose and try to represent that in this slide, that cities can be paired with common examples, maybe opposite examples. The city pair with Paris and the previous one also had opposite performances, and also cities that are in the same quartile, same quartile in a given dimension and same quartile in the overall index performances. Pairings are possible both in multiple ways. Yes.
Okay, and then my second question is, how did you deal with imports and exports? Like a classic example is, you put solar here, you say it's 100% renewable, but at nighttime it's importing electricity from a coal-fired power station. But it's outside the city because you don't put coal-fired power stations in a city because you don't want the...
In the Sustainable Energy and Climate Action Plans, the power plants does not have to be located in the city. It is accounted in the factor, the CO2 emissions factor. So location of power plants is not relevant, but I want to take your question a different way. In water consumption, for example, in water consumption in cities, that water consumption can be for industry or products imported to other countries, or maybe, so I'm looking at the blue water footprint for domestic consumption, which is trying to maybe subtract that part of water that would be used for industries and maybe them creating products that will be exported to the different countries.
We had the question from Ilya here, and then Peter.
Thank you. Well, thank you for digging into a lot of data. I will consider this big data problem, which is valuable for us for proposing the projects. Even the cities are similar or different, I think. Also, it's valuable for Convent of Mayors of European Association of Cities. So I propose not just looking at the cities, but also looking into smaller cities, smaller local communities, in order to have overall more broader picture. I were looking into cities you mentioned. I saw Dubrovnik, I saw Rio de Janeiro, but I didn't saw Novi Sad. I think next year after the conference, the sustainability index will improve and we will have it.
I don't remember if Novi Sad had a Sustainable Energy and Climate Action Plan or not. I believe it didn't, but I'm also hoping to include more cities from Serbia in the upcoming Novi Sad, because as I tried to show in the beginning of the conference, I'm adding more samples and trying to share more examples from the cities in each SDEWES conference. I'm motivated to do this. But at the same time, I realize that it's a big data issue, and I would hope that maybe cities are currently reporting data to a lot of different areas, and maybe there's open data, but organizing it into a composite indicator is something else. The reporting and the way that different data is, it needs to be more organized. Not searching into local statistical yearbooks or many other places, but organizing the data and supporting this with more open data. And we were discussing that maybe there should be some screens showing how this year's SDEWES index is performing, and maybe but this will be some years before this is realized, but it is possible to support, of course, the SDEWES index with more open data and organized data being reported. Maybe.
Maybe just one clarification. Are we calling this big data? It's a lot of data, but big data would be if we collected data from every single mobile phone that people have in a city and calculate congestion from that data. This will be soon possible. Google is doing that. They're collecting data from 1.6 billion Android mobile phones and informing us on Google Maps on the congestion. But I suppose you didn't use such type of data
Not
yet.
hourly or minute data, but I know that on the Tesla it is available, that you can download the data and see how it is performing in different routes.
So Peter was the next one and the last question, because we have to finish this session.
Thank you, Neven. I was going to go a little bit in the direction of how mature is this index or this methodology now? How applicable it is? Do you have any, say, city or city authority which knows about these studies or uses these studies?
When I was collecting data for this year's SDEWES index, so questionnaire was sent to over 100 cities, some already included in the SDEWES index from previous years, and some that will be newly included. They are looking forward to the results. So this is the updated results shared for the first time. I will be sharing this results also with the cities that are interested, but I also know that 2 paper presentations from different co-authors, at least 2, presented this year and last year. They used the SDEWES index for Hungarian cities. Viola, she's, I believe, also here. And for the city of Bari, they were looking at metropolitan areas located in the city of Bari, and they directly communicated with the energy manager of the city of Bari and used the SDEWES index with AHP approach. So I know that myself, I'm involved in SDEWES index, and there are some emerging areas, research areas, using the SDEWES index in their own projects that are ongoing. So I'm doing my best, but if you would also like to take the results of the SDEWES index and share it with your city, you're more than welcome, because it will improve the effectiveness of the research results.
Thank you very much. Siir?
Thank you.
Come on, guys. We have to tweet. Don't leave yet. I have an announcement to make. Just to tweet the photo. Okay. Thank you very much.